This is a look at trigonometric inequalities. I'm going to show you how to solve a few of them. Here we have 3 cosine of 2 pi x is greater than or equal to 0. First I'll divide both sides by 3, kind of get that out of the way. So now I say, okay, where's cosine positive? That would be first quadrant and fourth quadrant, since cosine's an x value. Because it's a 2 pi x, 0 divided by 2 pi x is 0. Pi over 2 divided by the 2 pi, is not divided by 2 pi x, just divided by 2 pi. So 1 over 2 pi, that ends up being 1/4. And then down here, 3 pi over 2 divided by 2 pi, that ends up being 3/4. So what we can see here also is we say 2 pi x is what we have originally. That's from 0 to pi over 2. That's first quadrant. Divide by 2 pi. You end up getting 0 to 1/4. And then again, we've got 2 pi x in the fourth quadrant, which is 3 pi over 2 to 2 pi. Divide by 2 pi. You get 3/4 to 1. So the overall solution for one revolution is 0 to 1/4, including the endpoints, and 3/4 to 1, including the endpoints. It's greater than or equal to. Okay, this one, I rewrote it a little bit by dividing by negative. Tan pi over 4x is bigger than 0. Tangent is positive in first quadrant and third quadrant, and this would be 0 divided by pi over 4, because remember these are pi over 4x corresponding to these points, so that's 0. This is pi over 2 divided by pi over 4, so pi over 2 times 4 over pi, so that ends up being 2. This is pi divided by pi over 4, so that ends up being 4, and then finally 3 pi over 2 divided by pi over 4 multiplied by 4 over pi, and that ends up being 6, and then we're back to 8 over here, comma 8. So first quadrant's from 0 to 2, third quadrant's from 4 to 6. You don't include the endpoints this time. It's a greater than, not a greater than, or equal to. Okay, for this one, this is a little trickier. It's quadratic. We want to factor it. So we have 2 sine x plus 1 times sine x minus 1 is greater than or equal to 0. This is going to be true if a couple things happen. If both of these are positive, or if both of them are negative. Okay, so, or if one's equal to 0. And so our points here are negative 1/2 and 1. And so I'm going to put in those points. So sine is equal to 1 up over here. It's equal to negative 1/2 down here. So we have pi over 2, and here we've got 7 pi over 6, and we've got 11 pi over 6. All right, if we're up here at pi over 2, then where sine is equal to 1, this is going to be 0. This will be non-zero. That'll work. So this point's okay. Now, if we want to find a place where any other place where they're both positive, the problem is that sine x minus 1 will never be positive. The biggest it's going to get is 0, because sine's never bigger than 1. So now let's look for where these things are both negative. Well, this one is going to be negative everywhere except right here at the very top where it's equal to 0. And this one, 2 sine x plus 1, is going to be negative in this section down here. And so down in here, the first factor will be negative, the second factor will be negative, so together you get positive. And so what we have is 2 parts to our solution. We have just the solution pi over 2, and in addition to that, we have this section here from 7 pi over 6 to 11 pi over 6, including the endpoints.